Hello everyone. Welcome to the presentation of our paper titled as Collaboration Challenges in Building Machine Learning Enabled Systems. In this paper, we basically try to understand what are the collaboration challenges that different stakeholders face while building a machine learning system. We found these 4 themes around the challenges and tried to provide some recommendations to mitigate the challenges. I'm Nadia Nahar from Carnegie Mellon University, and these are the amazing authors who worked with me to make this research possible. When I started working on this research project, in my mind, I used to imagine something like this when I think about a machine learning project. So there will be a notebook where I will write some code to train a model and have an output of a prediction in some form. For example, this is a face detection model that detects human face in images and which I can view like this in a square shape box. Now, this face detection model is not an application or product in itself. But if we want it to be used by end users, it might be embedded in a photo app as a component, which will look something like this. Now, this photo app does not only contain the machine learning model. It has many more components along with the model. For building this photo app, I have to provide some more functionalities, like a user interface where the user can use some buttons to upload a picture. I should give some storage system to store the picture, or even additional functionalities to manage or crop the picture. The machine learning face detection model will just be one component in this entire system. So it can be an end user application after adding all these engineering parts together and deploying as a mobile application. So for building this kind of systems, we need many different roles to work together. They can be within a single team or in separate teams. For simplicity, let's consider them to be in separate teams for now. So there might be a group of data scientists who we can call a model team who will be in charge of the machine learning model. There might be software engineers in charge of the other engineering parts who we can call as the product team. There can be a data team for managing data and many other different roles like managers, domain experts, and so on. So as all these roles collaborate together for this kind of project, our research question was to identify the collaboration points and the challenges between these roles, especially between the data scientists and the software engineers. Now, why did we anticipate that there must be some challenges in this area? Because we're having many hints and signals of problems from different sources. Let's look into some. As talking about different sources, so this article talks about how a large number of data science projects never even make it to production. And among the issues, they mention the problem of lack of collaboration due to siloed data scientists, as you can see in the highlighted portion. This article talks about the same problem of machine learning projects failing. And they bring out the problem of mismatch of assumptions between different stakeholders. Specifically, while the data scientists are concerned about accuracy, they can overlook the requirements of response time expected by other stakeholders, which creates a lot of problems. This article brings out how these different paradigms have completely different ways of working. Data science introduces a lot of exploration in the process, and we find it hard to incorporate the data science pipeline into the traditional software engineering process. We can also point to a lot of frustrations shared by Twitter, where people complain about process, not understanding the business context, and so on. So, this is why we felt it was important to look deeper into the boundary between the disciplines, because that's where a lot of problems seems to be. So this leads us to the research question to find the collaboration points and the challenges. For this, we conducted an interview study with 45 participants in 28 organizations. So as you can see in the graph, we tried to cover many of the different locations around the globe. But the main focus we had was on the company type. We wanted to recruit as many people as possible from the mid-sized companies because they neither had the experience nor the expertise of working on machine learning projects like the big techs have. But we also did cover big techs, startups, and non-IT companies. Another part we focused on was trying to talk to different participants from the same organizations. As you can see, we talked to many different roles, and our motive was to recruit multiple people working on the same product in different roles, like a data scientist and a software engineer, to get their different perspectives. So as it was a qualitative study, we tried to design the methodology carefully. We started off with 3 primary steps which we were doing continuously as an iterative process rather than being serial. So guided by an initial iterative study, we started off by scoping and defining the coding schemes and the interview guide. Then we did the semi-structured interviews and coded those using textual and visual techniques. In step 3, we did a literature triangulation. So these 3 steps were refining each other throughout the research, and finally we developed a theory that you can see in the diagram. And in step 4, we shared it with our interviewees to try to validate whether they agree with our findings or not. As I mentioned about visual coding technique, this is an example of how we analyze our interviews visually. So I don't want you to go deep down in the picture, but just to give you an idea, this is how we created diagrams for each of the companies. We tried to figure out the team boundaries and what were the collaboration points they are collaborating on. What were the challenges they were facing in each of those collaboration points. So we made hundreds and hundreds of diagrams like this to help us analyze the interviews. So this is what we came up with. There are 3 major collaboration points where the interviewees were facing most of the challenges. And there are some subcategorized topics on these collaboration points. As you can see in the diagram, there are some icons in front of each of the topics. Those are basically the themes around which the collaboration challenges were circulating. As you can see in the bottom of the slides, we have found 4 themes around the collaboration challenges: lack of communication, documentation, engineering, and process. You will find the same icons in the paper, which we kept to make it consistent. Now, not all the companies face all the challenges. Based on the team structure and working style, different teams face different challenges. I'll show you a few examples of this in a moment. For this, let's go deep down in one category of the collaboration challenges. In this collaboration point, we'll talk about the model and the product requirements. The primary collaborators of this collaboration point are the model team and the product team. The client and the management are also involved in shaping these requirements. As I mentioned, there is no global pattern of facing similar challenges, which is true for this collaboration point as well. I'll show you 2 examples of 2 different patterns of such organizations in the next few slides. As our first example, let's consider an organization named Organization A. This organization has a banking software, and now they want to detect fraud in that existing software that they have. So the requirements for this company flows in a way like this. The management and the product team first comes up with the product requirements, that they need this kind of component for the system, and then the product team talks to the model team, transferring the product requirements to the model requirements. Then the model team gathers data that they need to build the model, and the process goes on. So we categorize this kind of organization as organization of product first trajectory, because the product was developed first and then they felt the need of a model which came later in the process. The problems that this kind of organization of the product first trajectory faces are when the product team comes up with a requirement with the manager, they do not include the model team. As a result, they come up with requirements that might not be realistic. For example, the product team may decide to detect all the frauds in the product, but we know that machine learning models are not capable of providing 100% accuracy. Also, they do not understand that the model might detect some users to be fraud when they are not. So they do not consider this kind of cases while coming up with the product requirements. So now, when the product team talks to the model team that they need to make a machine learning model like this, the model team says like, okay, this is not possible for me to build. So it creates conflict between the product team and the model team. Also, as this is very late in the process, the success of the product is now put at stake. So, as you can see, we found 2 themes of the collaboration problems at this point of the organization. One is problem of communication because of not including model team during requirements process, and the second is documentation, because we have seen that often the product requirements are translated into the model requirements verbally, without any written documents. This elevates the conflict of the two teams more. As a recommendation, for mitigating the first challenge, we recommend to input data scientists early during the requirements gathering process, not afterwards. For the second challenge, we have the same old recommendation of maintaining formal documentations for both product and model. So as you can see, many of the challenges we mentioned can be solved by following our existing tools and best practices. Some demands for more research and education. So let's move on to the second organization, which have a different workflow and thus face different challenges than the previous one. Let's call this organization B. Here, they try to develop an optical character recognition software for a local language. The workflow for gathering requirements is something like this. The client, management, and the model team will come up with the requirements for the model at first, because OCR is the main module of the software and the model team is in charge of the project. Later, after the machine learning model is trained with data and so on, the product team will be inputted to make a wrap around the model and make it a deployable product. We call this kind of workflow to be model first trajectory, because model is the primary part of the product which comes first. This kind of organization finds similar problems of difficulty to educate client on machine learning, but it is way less impactful than the previous kind of organization because it is in the very preliminary stage of the project and can be solved with better communication. The challenge which is more problematic in this kind of organization is that when the model team is in charge of deciding the requirements, they often forget about the product requirements and only focus on the model requirements like accuracy. So the different product requirements like usability is completely forgotten sometimes. As a result, when the product is deployed, the client often complains like this. Okay, the model have very good accuracy, but we cannot use it because the product UI is not user-friendly at all. So as you can see, the team still faces the challenge of communication with client. This is mostly a problem of education. Some companies tackle this problem by conducting training sessions to the client and the product team before the project starts. The second challenge that you saw was a problem of process, because deciding model requirements before product requirements seems problematic. So for this, we recommend to emphasize more on team collaboration during the requirements, and also we need more research in this kind of area to come up with a good way to include machine learning in the engineering process. So we saw some issues in the collaboration point of requirements, and now let's move on to the second collaboration point of training data, where we found a lot of challenges. The three major stakeholders in this collaboration point are the model team, the product team, and the data team. The data team who is in charge of data can be within or outside the organization. The data team can be the team that collects data and labels the data, and also sometimes it can be the team in the organization who is responsible for managing the data access and distribution. We again found different patterns around different organizations. Let's see the patterns. So there are three patterns around training data based on the data source: provided data, in-house data, and external data. In the organizations using provided data, the product team is responsible for providing data to the model team. The model team does not communicate to the data team directly. They communicate to the product team who helps them get the data. Due to having distant relationship with the data team, in this kind of organization, the model team finds it difficult to get enough good quality data and also have problems getting help understanding the data. For the organization using in-house data, they often have an internal data team who manages and maintains the existing data of the organization. Here, the model team communicates with the data team to gather the data that they need for building the model. The teams using external data are one of two kinds. Either the model team can get data from a public source without having any influence on the data team, or they can hire an external data team for themselves to gather the data. Although in this last two types of organizations, the model team works with data team directly, they still have a lot of complaints in this collaboration point. Let's look at a few. For this, let's go back to the previous example of organization A. As the banking software was one of the existing products, the organization already have a data team who manages the data of the entire software. So the organization falls into the category of in-house data. Now you can think that as the data team is already in the organization, it must be easy for the model team to grab the data that they need from the data team directly. But no, we didn't find that. Often in this kind of organization, the model team stays in a low power structure. They have very little influence on the organization and the data team. So they find it hard to access the data that they need. And often the organizational lengthy process makes it harder for them to get access to the required data. To make it worse, often the model team cannot even access the data team directly. The product team have to be a mediator to get the data from them. And as the product team and the data team are already busy with many other stuff, the model team often shares frustrations on not getting help on understanding the data. So this kind of organization faces all these 4 theme challenges in its collaboration point. They have a problem of not getting access to data due to power dynamics. There is literally no documentation of the data present which they can use to understand the data. No process to call for help for data understanding. And last but not the least, in case of changes in data, which happens quite often as many different teams use the same data source, there is no infrastructure to detect those unnoticed changes or handle it. So as you can see, we found a lot of complaints in this collaboration point on training data. And there are many more. So these collaboration points need special attention while planning for the entire product from the very beginning. A few recommendations would be to explicitly plan for data collection, plan to access domain experts to help understanding the data, keeping formal documentation, and appreciating engineering effort for automation and data monitoring. So you can see, I showed 2 problematic topics on 2 collaboration points and only talked about a few challenges around them. There are many more challenges that people face in these collaboration points. Our 3rd collaboration point, the integration of model with the product, is another problematic one, where the model team and the product team members have a lot of conflict around code quality, boundaries and responsibility, siloing data scientists, model and system evaluation, and so on. So I can keep talking about the challenges in these collaboration points for hours. I hope you read the paper and get to know all our findings in these collaboration points. So these are the recommendations we have for mitigating some of the challenges around these 4 themes. Defining explicit process and responsibilities and boundaries can be really helpful. Documenting the interfaces between different teams are very much needed. We often do not appreciate engineering effort much, but having engineering support for data validation, deployment, and monitoring of the model can be useful. And lastly, establishing a team culture of mutual understanding and setting a common vocabulary seems very important. In summary, collaboration problems can lead to failing of machine learning products. Thus, it is an important topic which we need to put more emphasis on. From talking to 45 practitioners in the industry, we figured out the main 3 collaboration points that need special attention. And we also try to provide some recommendation based in the industry best practices and existing tools and techniques of software engineering. A lot of the challenges can be mitigated with better education, communication, and documentation. And there is a scope of research in defining a good process for this kind of machine learning systems. And lastly, we need to appreciate the engineering effort more to make this kind of product successful.